the cameras.
Okay, hello, welcome to Klein's Geometry. Today we're going to talk about section 11.3, sector area and arc length. You're probably wondering what a sector is. It would be like a pie-shaped piece of a circle. And we're going to be talking about how to find the area of the sector. And then arc length would just, we've talked about finding the measure of an arc in degrees. And the measure equals the central angle. Now we're going to talk about finding the length of the arc. If you were going to take a string and trace it along there, how long would that string be? So now we're going to be talking about inches, centimeters, that sort of thing. Okay? So that said, let's put into your notes the sector of a circle. It's a region bounded by the radii, two radii, and their intercepted arc, or a central angle and its intercepted arc. So here's a nice picture of sector ABC. We know that this angle measure is the same as that angle measure. And to find the area, notice it's just a fraction of the circle. So to find the area of just this fraction, we're going to use the area formula for a circle, pi r squared, and we're going to multiply it by this fraction of the circle. There's 360 degrees in the circle, and whatever the measure is of this arc or the measure of this angle, that measure over 360 is the fraction of the circle. So that's your formula, key formula. If you want to find part of a circle, a sector, you find the whole area of the circle multiplied by a fraction. The degree measure out of 360. Okay, make sure that's written down and let's use that. Okay, so now we're going to find the area of sector HGJ, so this shaded area right here. And we're going to get the answer in terms of pi and rounded to the nearest hundredth. So whenever you're told find the area, just write out your formula first. Pi r squared, area of the circle, times the fraction of the circle. And I see that this central angle is 131 degrees, so that's what I'm going to put in there. And I see my radius is 12, so that's what I'm going to put in here. 12. And, you know, this measure, notice it's got a little degree symbol there. So when you're looking for the degree, that always goes here, over the 360. And then the radius won't have a degree. That's just a length that goes from the center to the edge. Now I'm just going to calculate this out. And in terms of pi, I'm just not going to calculate that. In my calculator, I'll write 12 squared times 130 over 360. And when I do that, I'll get 52.4 pi. And remember that I see an m over there, so I know that's meters, that length. So the area is going to be square meters. And then it says round it to the nearest hundredth. So now I'm going to take this 52.4 times pi, and it'll be a little more than 3 times that, because pi is a little more than 3. And I'll get 164.62 square meters when I round it to the hundredths. Now this is an exact answer, and this is an approximation. Both good. What you want to do is look at your directions to see which the book or I am asking for. Okay? Now let's look at a practical application. A windshield wiper blade is 18 inches long. To the nearest square inch, what is the area covered by the blade as it rotates through an angle of 122 degrees? Well, if you need a visual on this, think about your car windshield. And here's my wiper. Excuse me, my wiper is 18 inches long. And it's going to go on an angle of 122 degrees. So if I want to find that, how much of my windshield's getting covered, I can do the same thing we just did. We're going to use the formula for the area of a sector. Even though we don't see the whole circle, we know that's what it's going for. So pi r squared times the measure of the angle over 360. The angle has the degree symbol, 122 is going to go there. The blade is 18 inches long, so that's our radius. That's what will go there. So we're going to plug that in. And it says to the nearest square inch. So now when we round it, we're just rounding it to the nearest inch. So we just pi times 18 squared times 122 divided by 360, put it all in your calculator, and it's going to be about 345 square inches. And it says inches up here, so we've got square inches in our area. Okay, now we talked about finding that fraction of the area. Now, what about arc length? Well, that's a fraction of the circumference of the circle. So they're very much related. Arc length is the distance along an arc, right here, and it's measured in linear units, okay? So if this is degrees, then this, the length, would be like inches or centimeters, that sort of thing. And we can find it the same way that we just found sector area. We're going to start, since it's a distance along the arc, we know the whole distance around the circle, circumference, 2 times pi times the radius, and we want a part of that. So we're going to take that fraction of the circle that this arc is going around, which would be this degree measure, or this degree measure, over 360, that fraction of the circle. This would be a degree measure. Your length will not be. So find the arc length of F to G. Well, I'm looking for that length. I know from this that the measure of this central angle is 134 degrees. The measure of this arc is 134 degrees. But I want the length of the arc. So I'm going to start with my formula, not for the area of the sector, for the length of the arc. And 2 pi r, circumference, times the degree. I know a radius, it's 8. The radius is the same anywhere on the circle. And I'm looking for a degree, and I see there's my degree measure, 134 over 360. Plug it in, and it says in terms of pi, I want an exact answer, and round it to the nearest hundredth. So first, I won't use my pi. I'll multiply 2 times 8 times 134 divided by 360. And I'll get 5.96 pi centimeters. Because my radius is in centimeters, so we're measuring the distance around the circle in centimeters also. And then when I multiply this times pi, it'll be a little bit more than 3 times it, 18.71 centimeters. That's how long it is if I were to take a string and go from F to G along that arc. So 18.71 centimeters and 134 degrees. So we can describe arcs 2 ways. Looking one more, find the arc length with a measure of 62 degrees. The circle has a radius of 2 meters. We don't even need a picture. We can just write down our formula for the length of an arc. I'm going to plug in 2 for my radius and 62 in here for the measure of my arc, because I've got a degree symbol here, so I know that's what I need. I'm going to substitute that in, and then I'll just, it says in terms of pi and round it to the nearest, so I'm not going to use pi first. I'm going to go 2 times 2 is 4, 4 times 62, and then divide it by 360, and put a pi after it, 0.69 pi. And it said meters over here for the radius, so I know that's meters. And remember, length is not square. And then if I multiply this by pi, I'll get 2.16 meters. So that's all we're doing for these. So, in summary, sector area of the circle times a fraction of a circle. Here's your formula. Arc lengths, circumference of a circle times the fraction of the circle. Here's your formula. Make sure you've got that in your notes. Make sure you've got a couple examples in your notes. And see you in class.